Watch what happens when I ask Claude Code to show me my customers table. We'll fast forward through this for a second. Now, what you can see on my screen are realistic looking emails, account numbers, social security numbers. So everything you saw and you see here on my screen just left my network and it is now sitting in Anthropic servers. This, thankfully, is a synthetic data set, but the pattern is a very real pattern where it can happen when you access sensitive data, when somebody else is accessing sensitive data that you might be on via their tools that is stored in their database or via files that they are feeding into AI for data analysis. What I just showed you in Claude Code there is indicative of this report from IBM, where it says 13% of organizations reported breaches of AI models or applications, and 97% of those instances reported lacking proper AI access controls, meaning AI probably had access to sensitive data like I just showed you. Today, I'm going to show you some practical solutions you can implement quickly to fix this security problem and mitigate this risk of information escaping via AI. We are going to scaffold a scoped Snowflake role for AI, build a masking view, hash the personally identifiable information or PII, so the AI can still do analytics, but never see the raw values like you see here on this screen. And then we will run the bad query at the end to watch it successfully get blocked. With that, let's get into protecting some PII. Before we build anything, we need to understand what the default AI setup actually has access to. Now, if you followed my other videos for connecting Claude Code to Snowflake, Databricks, BigQuery, or any other database, when you authenticate through an MCP server or command line interface or CLI, the AI does not get its own role. It uses whatever role the MCP server or the CLI authenticates as. And in most cases, that is your personal analyst role, your personal role that you utilize to authenticate to those systems, which means whatever you, or in this case, whatever I can see in Snowflake, Claude Code can see. And whatever Claude Code reads ends up in the context window, which gets sent to the AI provider. Now, when I first connected my Claude Code to Snowflake, I had a role that admittedly could see everything in my database, which is why I'm making this video, because I have committed this mistake, exposed myself to this risk in the past. As we adopt AI through more and more companies, give it access to more and more of our data, that we really think about how to protect this sensitive data and procure the right permissioning, the right structures to ensure that sensitive data for different individuals and sensitive data that is valuable to our company and would be a risk if it was exposed is properly protected. Now, in my previous video, I covered around this topic of data privacy, PII, and AI. I noted that you can actually opt out of having your data retained with the different AI model providers. However, this does not help you if AI is seeing the data that you did not want to send over in the first place, that is sensitive. And so that is the part that we're solving today, how to not send that data to AI in the first place. Now, one of the things you can immediately do to audit your access to PII with AI is by asking Claude Code or whatever other AI coding assistant that you're utilizing. So you can see here that I've asked Claude Code about my data warehouse. In this demo, I'm going to be utilizing Snowflake to assess the grants I have for the different objects within my Snowflake data warehouse for the role that I'm utilizing, and then also give me an assessment of the other roles that have access to PII tables, like the customers table that we saw above. This ran off screen and I also gave it this additional prompt to have it get the roles for my user. And you can see here that my user has access to account admin and analyst, and these have the privilege on prod.raw.customers. All of the roles I have available to me as a user that's authenticated into the session with AI. So AI has access to this table when I'm logged into these roles for account admin and analyst. And I want to emphasize, even if you don't have the account admin role, which is the highest level of role you can have in Snowflake, and you just have analyst, which is a select read only, that is enough for AI to ingest that sensitive data. And just to expose another risk here that is unrelated to PII, but if you do have account admin privilege like I do, and you're the administrator of your database, or you have a higher level role, then Claude does have access to taking actions like drop database prod, drop table prod, if you have these specific commands unconstrained like they would be in the Snowflake CLI. However, you can control these more with the Snowflake MCP and require it to ask permissions before taking actions like this, or prevent Claude from doing this entirely by prohibiting it within the MCP permissions. If you're curious how to control those permissions, I cover it right around the 30-minute mark of my Snowflake and Claude Code video, which you can see in the card above here. Simon Willison, the person who is one of the people attributed to coining the term prompt injection and also co-created Django, has a name for a combination of risk for AI agents called the lethal trifecta, which it is access to private data, ability to externally communicate, and exposure to untrusted content, as you can see below in that visual and in the title of this article. Now, looking back at my Claude Code session, you can see I had access to private data, and I have the ability to externally communicate if I've hooked it up with other tools. And say I'm searching across the web, well, it is possible that I have exposure to untrusted content. So all three of these criteria are met in this scenario, making my AI agent that I had there in the lethal trifecta. And the point here is that many people's default setup by connecting Claude Code with Snowflake may put them in this lethal trifecta. And so when we talk about a safe setup, this is what we're designing against. We know what the problem looks like, how to define the problem, where the default setup gives our AI coding assistant, Claude Code, more access than it needs to our data warehouse, Snowflake, and that data flow takes the raw data, the unmasked PII values from our data warehouse off of our network to the servers for the AI platform, and it is being read there. So now let's actually get to the most important part of this video and build out the practical solutions to solve this, to mitigate this risk, so that you, your team, whatever other data professionals you share this with, can do the right thing and make sure that this data is safe. There are three architectural principles that the rest of this build follows. There are three simple ideas, and you'll see how everything else that we do when it comes to actually building follows from them. The first key principle here is schema segregation. Now, as you can see in this 4-layer diagram, there's different categories of data. And up at the top of this pyramid here is your PII, your personally identifiable information. And that sensitive data should live in its own schema. You can call it PII, sensitive, raw, production raw. The AI agent role, whatever you call it, should never get usage on that schema and readability, which means it literally cannot reference those tables. Rather, the AI agent should only see a curated PII schema. And in that curated schema It should not have any of the base tables that have the viewable raw information inside of it. This is documented Snowflake best practice as this schema becomes the security boundary for the AI agent. Now, for the second principle, which you can see here in the diagram below as well, there is hashing as irreversibility. Sometimes AI is still going to need PII columns. Say for email, maybe there are joins, group by statements, aggregations, deduplications, where you might need one of those PII columns. Well, you can apply a hashing algorithm like SHA-256 or SHA-2-hex, where it essentially turns the value, the raw value of the email or whatever other piece of PII information into an unrecognizable string of characters that is designed to protect the real value of that piece of data. If this doesn't make sense right off the top, we will get into some examples that you will see shortly. The third principle is identity selection, and this is about which Snowflake user and role the AI authenticates as. This shapes everything downstream. So the default move might be to just use your personal Snowflake user and set a different default role. However, that is not the best approach in modern Snowflake. As of 2024, secondary role aggregation is on by default unless that was configured differently within your Snowflake instance. And what does that mean? Well, basically every role that is granted to your user is silently active in every session. So if I have account admin, even if I'm in a more restricted role, alongside that primary role, I'm going to still have access to that other data because I have those secondary roles already given to me. So the better question to ask is, which user identity does AI authenticate as? And this really encapsulates the three patterns that you see in this graphic here, where pattern one describes what I just described, your personal Snowflake user, and this is best to not use for AI work. Whatever you have been granted, the AI session inherits. And so if you have PII access, sensitive data access, it will also inherit that if you have that secondary role permission. The second pattern is what I recommend when you are directing AI to query the data on your behalf, a per human AI user. You can have this per human AI user set as a service type account with a key pair authentication or whatever authentication suits your organization or data warehouse best, and have only, and this is the key part, only the AI agent role granted to it. Mine in this example, as you can see, is called kchalmers_AI. And this is the recommended default for individual analysts and engineers, which allows for the cleanest query history attribution, the narrowest blast radius of accidentally messing something up, and allows for per person authentication. And now the last pattern is the shared service user. And this is the example for if you have an autonomous AI agent, it basically has the same role exacted to it as a per human AI user, but it's utilized in autonomous scenarios and that is not tracked with an individual's usage of that specific account. So these are the three different patterns, and I would recommend the second pattern. Admittedly, maybe in other data warehouses where you don't have that concept of secondary role grants, or you have that turned off in Snowflake, that this pattern would work for your individual user. However, I like the distinction between what is AI activity and what is my individual user human activity. And having that broken out allows you to really define how am I instructing this AI assistant or my AI agents to query the database versus how am I doing that as an individual. It allows that nice distinction between that activity. So it has benefits beyond just security. So now let's actually begin the build. And here you can see in my Claude Code session, I have a prompt ready to go asking Claude Code to generate the K Chalmers AI service user and the AI agent role. Now, this is something that you could ask Claude Code to do for you, but the idea here is that we want to be safe with our data and not have AI unnecessarily exposed and utilizing things like account admin if you have that access. And so the better practice here would to actually be to run these queries yourself and have AI, sure, help you write the syntax for it. And maybe you do that inside the actual chat interface of Claude Chat or ChatGPT, as opposed to doing it within a coding tool that has access to your database. But now you can run these queries yourself as a user, creating this user and creating this role and granting the permissions to, or work with your database administrator who can do this for you. Now, if you look at this, you'll notice that there's a couple things missing in this SQL statement. First of all, there is a missing RSA public key where you can actually generate an RSA key pair locally and then put that into Snowflake by following instructions from Claude. I will put these instructions in this repository, as I will put the links to all the information in the description below, so you have access to everything. This will be in there as well for how you can do that. And then additionally, there's no warehouse, where you have an option if you want to procure a specific warehouse for your AI user and your AI role. It might be worthwhile to do that. That way you can track compute costs associated with that particular user as well. Note what is not here. There's no grant usage on the raw schema or the schema where I have that open PII information. The role can only reach the curated schema, and this is only going to have AI agent available to it as a role and nothing else. Again, this is just what I'm naming it here. You can follow the naming patterns that go with your business, with your data warehouse, but it's important that this is very strict in its scope. I ran it off screen, and now you can see I have the kchalmers_AI user successfully created. And I've also added in some additional SQL code in here just to really spell it out. And I actually created it with a different RSA public key, but I wanted to include this previous one I created that is not in use to show you all, to make sure what this looks like if you decide to go this RSA public key route. There are multiple ways to authenticate to Snowflake for a user, and this is an easy automatic way for an AI user, so you don't have to re-authenticate every time. However, you can set this up with dual factor authentication or OAuth, whatever works for your Snowflake instance or your particular data warehouse that you're using along with the enterprise. I've utilized the account admin in order to create all of these different features here, where I need that role in order to have access to create this warehouse for the AI warehouse, and the role, the user, and then we can see all of the different grant usage statements that have been created here. And if I scroll over as well, inside the repository that I'm linking below in the description, you have access to actually that specific query as an example, as well as the template here if you're utilizing Snowflake that you can copy and paste and adjust for your specific use case. Now we have the user setup. What is the next step? Where do we need to change this? Well, the first area we need to go, if we have the MCP set up, is Snowflake. And you can actually see where the configuration location is here for Snowflake underneath all of these details with the Snowflake MCP server. And then we're also going to need to change our Snowflake CLI if that is how you've connected Snowflake with Claude Code. Basically, wherever you've connected previously, utilizing your personal user, we'll need to track that down. Let's say you have the Snowflake MCP configured. First, we're going to start with the MCP and running these different commands here. In case you haven't set it up or you want to see it, you also need to make sure that you have your private key available, and you can see this private key that I have available underneath the .snowflake folder here, where I have the kchalmers_AI. And so scrolling back over to my cursor here, I'm going to run this command, Claude MCP remove snowflake, and we can see that has been removed and the file has been modified. Then as the second portion, I pasted in this MCP add command for Claude. We'll enter that and we can see it's been added. And so now let's launch Claude Code and actually test it with this MCP. I have now launched Claude Code and I will type in \MCP. And we can see I have Snowflake here. If I look at the configuration, I can see it's utilizing this kchalmers_AI private, meaning that it is connected via my kchalmers_AI user. And so let me test the connection and just say, select the current user. And we'll see what it comes back here within a second. It took about 16 seconds, and now we can see that we have the kchalmers_AI with the AI agent role available. For the Snowflake CLI or Snow CLI, you might see that you have a connections.toml file or a config.toml file like you see here. And both of these need to be changed to utilize your AI user. And you can find these again in the same location underneath the .snowflake folder, which is typically under your root user if you're utilizing a Mac. And you can see that here, which is just above the area where I stored the private keys for this walkthrough. And for this, I'm actually going to utilize the easy way of just having Claude change it. You can change your account like this. What I'm going to have Claude do is make sure that this also edits to have my kchalmers_AI user also be my default connection name. And so I'm going to continue with the prompt as I had previously asked it to make those changes for me. And we'll come back here once these two files are changed. Okay, Claude made the changes according to my instructions here. And we can see now in the connections.toml file that it has my Snowflake private key configured with the kchalmers_AI username, and then also my default connection name set to kchalmers_AI. And then I asked it to select the current user using the Snow CLI, and we can see that that has returned back. So now my two primary methods of connecting to Snowflake via Claude Code are utilizing my AI user and AI role, which in the grand scheme of things, this is the most critical security step that you can do to prevent AI from reading sensitive data within schemas that you don't want it to. When you have it segregated like this for your user and to a specific role, then it has no way of being able to get access to that. I see it as the most impactful and critical on this way to securing your data and making sure that sensitive data does not make its way to AI without some protection. For the second major practical portion of this video, we're going to talk about actually implementing the transformation and masking the PII data. And really within here, what I wanted to cover first actually is the creation of that prod curated role, which the curated schema is what we're going to call the schema that has been curated for our AI agent role and is accessible to that AI agent. And this means that the PII has all been transformed and is not actually visible to that AI agent, PII or sensitive data. And so the first thing you need to do here is essentially create the schema. Now, I had created it going into this video, but I wanted to run this portion of it just to show how this segregation actually works. And you can see this in the code that I have in the repository. Now, for the second portion of this, it's actually going into creating the masked values for our customer data. And we can see that it does a select statement. And here we're creating a view called customer masked, which has the masked customer data for AI agent with that explicit purpose. and it does a few different things to mask it, where it applies a SHA-2-hex hashing algorithm to email, and then also does a masking to the account number. And it doesn't even utilize the SSN value, since that's not going to be needed with our AI agent. And I would recommend that pattern, where if you don't have to include a particular PII or identifier within a table or view in the curated schema, then you can just exclude it and leave it in its previous schema. And here we can see that I actually asked Claude Code to help me generate this view called customer masked, which it's not displaying prettily in here, but you can see it helped me write out the code. But ultimately, since I already took away the account admin access, I'm having it write out this information for me, and then I'm going to be the one that runs it and actually creates it. Now, with all of this masking code for our data actually built, which you can see here, it's available in 0.3 create masking layer. Let's talk about it a little bit, where you have a few different options where I can run this customer masked and it will work perfectly fine. However, there is a risk here. Whenever you hash a piece of data, say email, if there is, say, a string value of ABC, and that hashes to one particular value, it's always going to be the same value every single time. And so if, say, a attacker or somebody who had access to a bunch of personal identifiable information decides, oh, let me hash all of these 1,000 emails. If one of those 1,000 emails lives in your database and is hashed, then those hashes will match between those two emails. Now, to be super safe, how can we prevent that mashing or matching between hashing? I just made that up on the spot. Well, you can actually insert random characters into the hash. And I wasn't familiar with this specific term before doing the research for this video, but you can utilize a salt, which essentially it's a randomly generated number or character that you can add to a column to thus randomize the hash. And if we scroll down here in my script, I have an area where I create a table for salt keys that associates a customer ID and a specific salt. And so that way there's always going to be a consistent relationship between the customer ID associated with an email, an SSN, etc., that row in our customer's database or data table, excuse me, and that salt value. And what we'll do is we will insert that customer ID with the random string and call it salt keys. And so if I select from this table, and let me just do a quick select star, then what we will see is the salt has this essentially random string of numbers. The customer ID is this random string of characters, excuse me, and the customer ID has this. So everyone's email that will be hashed is going to be associated with this random string of characters. Thus, when it is hashed again, there's going to be no way to be able to match a specific email. Now, with this salt created, we can apply it to our view. So we'll first drop the previous view that we created and then create or replace this view customer masked with the SHA-256 and per row salted. And you can see that here that the salt is actually concatenated in with the value. And that's not the only way to create it utilizing a view. If you desire better performance, say you're using a significant amount of data and you have a lot of PII, you can also use a thing like a materialized view if that's available to you in your data warehouse, or in Snowflake's case, a dynamic table, or create a table as well with some procedure or data loading task that dynamically and consistently will load the new sensitive data that you want available in this curated schema to that specified table. And so now that we have this actually created, Let's go through and select from our dynamic table. And we can see here now that there's a customer ID, the first name, the email hash, the account number mask, the city. If we move my head here a second, we can see all of the other information that was there as well about this specific customer. And so this is just showing you different ways you can do it. You can hash the whole first name, hash the whole account number as well. If you don't want 4 identifiable digits to be available within that, available to AI, there's a lot of different ways you can do this, but you can apply this pattern to whatever data that you deem sensitive and whatever personally identifiable information like email, phone number, full name, address, social security number, etc., that you have in your database and would be valuable for AI to analyze, but not to actually access and read. Let's actually test this now in Claude Code. First, before we do that, we need to make sure that our AI agent role can access it. The access has been provisioned on the dynamic tables. And we will go over here to our cursor session. We have this query prepared for asking it to query the view in the dynamic table and the curated schema in Snowflake. And then I will type up a secondary query here. And can you try to get the raw PII upstream from these? And we can see that it returned back with the view customer mask, the customer mask DT. So both of these work appropriately with the hashing algorithm as we set it and the masking for our account number. And it is saying that it authenticates on account admin, which actually is not true. I think that is something that's left over from context, since if we check our MCP, we can see our Snowflake is feeding in from K. Chalmers AI. So even though Claude gave me the strange answer here that said it was authenticating as account admin, it was actually wrong. And it wasn't doing that because of the protections that we set. So, which is a good marker to show that even if Claude thinks it's in an admin role and tries to access this data thinking that it can do that, then it won't be able to with this role and this user applied to it, and the schema segregation applied with this masking. So we have some protections here working with it to make sure that our data is in a safe and secure spot where we cannot give it to AI and not have that PII fed into it. A great part about this setup too is that you can actually still conduct analysis on your data. And if I say, hey, show me churn rate by city for customers acquired in the last 90 days using the customer mask view, then it will be able to conduct this analysis using the data in that table. Having your curated PII or view or dynamic table, whatever it may be, with sensitive data in it, available in this curated schema allows you to still conduct analysis and connect it to other areas of your data that you're not worried about AI accessing. And that's the whole purpose of this, right? To empower AI to do more dynamic data analysis and enable you as a data professional to get more done and with this tool at your hands in a safe way. I also want to acknowledge that what I just showed you is one way to safeguard your data and safely connect your data to AI. There is more than one way to do that. For example, Snowflake has a dynamic data masking where you're actually able to create a masking policy on a column by column basis, depending upon the role of that user that they have access to. For example, I could say when the current role is AI agent, then hash this specific column, otherwise return that column's value. So you have that ability to do it in line, where if you set up your AI user only accesses AI agent role, then you don't necessarily have to rearrange your schemas in this way. There are other approaches as well for other data warehouses with similar sort of dynamic data masking or similar things that I showed under different syntax. But generally speaking, I do like my approach because it creates a universal schema that is safe to connect to, and it doesn't involve masking on individual columns. But I'll leave that up to the individual user. I didn't show this specific dynamic data masking because it requires an enterprise edition, and that is not the version of Snowflake that I have access to. And that is it for this video. To recap the 3 practical principles you can apply with your data. First, apply schema segregation. So sensitive data lives in its own schema the AI cannot reach, and the AI can reach a curated schema that masks or excludes that sensitive data. Secondly, apply hashing with per row salts. So the AI can still do joins and group bys without ever seeing the raw values. Thirdly, apply identity selection. The AI authenticates as a personal user with only the AI agent role granted. So even secondary role grants to your own personal user cannot widen its blast radius. And to be clear, this build is not a complete defense. It protects against AI provider data exposure and AI user privilege. It does not protect against other forms of attack, say like prompt injection, where an attacker tries to trick the AI into running a query you did not authorize. However, it can help mitigate dangerous access to info you do not want to expose in a case that does happen. If this was helpful, please hit the like button and subscribe. I make videos like this almost every week. As you can tell, this one took a little while given I'm in a different place from where I started at the beginning of this video, but I hope this really helps with data professionals and people who are working with sensitive data. That way we can create the most protected setup possible for all the sensitive data that we work with. As always, thank you so much, and I'll see you in the next one.